Hey everybody. In class, we looked at graphing compound inequalities. That's when we have two inequalities at the same time, and they're usually joined by the words or and. Right now, we're going to look at how to solve compound inequalities and then graph the solution. So this is a little bit more complicated, takes a little bit more work, but if you pay attention, you get the notes down, you're going to get it. We are going to start with an or compound inequality, right? We have the word or here. So our first inequality, we have 2x plus 3 is less than 9. So first thing we want to do is solve this so we can figure out what x is. So 2x plus 3 is less than 9. I'm going to subtract 3. That's going to give me 2x is less than 6. And then I divide by 2. And I get x is less than 3. Okay? Now we're going to do the same thing over here. Draw my line through my inequality. We're going to add 6. Add 6. We get 3x is greater than 18. We divide by 3. And I get x is greater than 6. So my new inequality is x is less than 3 or x is greater than 6. So now I'm going to need a number line to graph this. As usual, I'm going to want to have three numbers. I'm going to go with 0, 3, 6, and I'm going to put a fourth number, 9. So 0, 3, 6, and 9. Now, my first inequality, x is less than 3. X is less than 3. That's going to be an open circle because it can't be equal to 3. And I want to shade in all the numbers that are less than 3. Okay? Now, x is greater than 6. That's an open circle on 6, and that is all the numbers to the right, all the numbers that are greater than 6. So here I have my solutions right here, and my graph that shows where they are on the number line. So that's how you do an or inequality. You just solve them both, and then you graph it on the number line just like we practiced in class. With the and inequalities, it's going to get a little trickier. Let's take a look at one of those now. With the and compound inequalities, we have to be very careful about how we read this. This says that 10 is less than or equal to 2y plus 4, which is less than or equal to 24. So this right here is the number, 2y plus 4, is the number that's greater than or equal to 10 and less than or equal to 24. So when we rewrite this, I'm going to write it in a way that I can solve it. So I'm going to break this apart and write it as two inequalities with the word and in between. So we can say that 10 is less than or equal to 2y plus 4 and 2y plus 4 is less than or equal to 24. Now that I have these separated in two separate inequalities, I can just go ahead and solve. We'll draw a line down and we'll subtract 4 here. 6 is less than or equal to 2y. We divide by 2. And we get y is greater than or equal to 3. Over here, we're going to do the same steps because it's the same expression. Minus 4. 2y is less than or equal to 20. And we divide by 2. And we get y is less than or equal to 10. 3 is less than or equal to y. And y is less than or equal to 10. Now for the number line. Draw our number line here. Okay, I'm going to go 0. Now we've got 3 and 10 here. You know what? I am going to just use 3 and 10. We're just going to sort of ballpark it. And as long as we have the numbers marked and the spacing looks about right, we're good because we're just trying to show where the solutions are. Y is greater than or equal to 3. So we can do a closed circle on 3. And we know we're going to be going to the right. and we have y is less than or equal to 10. So we can put a closed circle there. And since it's y is less than or equal to, we know we're going to be going to the left. And we saw this in class. When we have an and inequality, we have two circles with the space in between shaded in. In this case, our circles are closed. And we can write our solution as 3 is less than or equal to y, which is less than or equal to 10. All right, I want to try one more and example because I feel like those are the ones that give people the most trouble. And usually that trouble starts with the way they write it. So once again, this middle expression here is both greater than or equal to -5 and less than or equal to 2. So when we break it up and we connect it with the word and, that's how we have to write it. -5 is less than or equal to -x minus 3, and -x minus 3 is less than or equal to 2. So now we can solve it by solving both of these separately. We add 3 to both sides. That gives us -2 is less than or equal to -x. Then we divide by -1, which gives us x on the right side, gives us +2 on the left side, and we have to flip our inequality because we divided by a negative number. On the right side, we do the same steps. We're going to add 3. That gives us -x is less than or equal to 5. We divide by -1, and x on the left side, -5 on the right side, and our symbol becomes greater than or equal to. Now, for a number line, we have 0. We'll put 2 over here. We'll put -5 further that way. And we're going to plot our points here, our graphs. So we've got 2 is greater than or equal to x, which means that x is less than or equal to 2. So since it's less than or equal to, I want to make sure I have a closed circle. And x is less than or equal to, so it's been going to the left. X is greater than or equal to -5. So closed circle, and we're going to the right. And this is an and inequality, so as usual we see our two circles with the space in between shaded in. That shaded space represents all the possible values of x. And we can rewrite our solution as 2 is greater than or equal to x, which is greater than or equal to -5. So this is perfectly fine because we have everything in order. The x is in between. Sometimes people like to write it like this. They put the smaller number first, and the largest number, the maximum, they put last. So either one of these is a perfectly fine answer.